Good morning. Today's topic is conductance and conductivity. First, what is conductance? Conductance is the flow of current and it is denoted by letter G. Okay, so we can explain conductance is it is the property of conductor which facilitates the flow of electricity through it. It is the property of the conductor which facilitates the flow of electricity through it. Okay, and it is denoted by letter G. And what is resistance? Resistance is the resistance offered to the flow of current, and conductance is the flow of electricity through the conductor. So we can write R. We know R is a resistance. So G will be equal to the reciprocal of resistance. So resistance is ohm. The unit of resistance is ohm, and unit of G is ohm inverse, or we can write mho. Okay, G is ohm inverse and its SI unit. SI unit of G is Siemens. Siemens is denoted by letter G. Okay, now magnitude of conductance depends on three important factors. First one, number of ions in the electrolytic solution, number of ions present in the solution. Then second point is magnitude of charge on each ion. Magnitude of charge on each ion. Okay. Then third point, ionic mobility. What is ionic mobility? Ionic mobility. Ionic mobility is the distance travelled by an ion per second under a potential gradient of 1 volt per centimeter. Okay, distance travelled by an ion per second under a potential gradient (1 volt per centimeter). Okay. Next, let us explain what is conductivity. Specific conductance or conductivity. Or conductivity is denoted by kappa. This is called as kappa. Okay. Now, we know specific resistance. Specific resistance is denoted by rho. Okay. And specific conductance kappa will be equal to the reciprocal of rho. Okay. And we know R is equal to rho L by A. Okay. So 1 by rho will be equal to 1 by rho will be equal to L by RA. So we can write kappa equal L by RA. Okay. This is kappa or specific conductance, or we can write conductivity. So conductivity will be equal to L by RA. So we know 1 by R will be equal to G. So G L by A. Okay. For G, the unit, what will be the unit of kappa? Unit is, G is Siemens, and this is centimeter, this is centimeter square. So Siemens centimeter raised to -1, or SI unit will be SI unit Siemens meter raised to -1. So this will be the unit of kappa. Okay. Now L by A. L by A is called as cell constant or G star. Okay. So L by A is the cell constant or G star, where L is the length of the ratio. It is the ratio of the L is the distance between the electrodes. So this L by A cell constant is the ratio of the distance between the electrodes, that is L, and the area of the cross section of the electrode A. Okay. So L by A is the cell constant. Okay. Molar conductance lambda m, noted by lambda m. Okay, what is molar conductance? Molar conductance is the conductance per mole of solution, or we can write conductance of all the ions produced by ionization of 1 molar solution of an electrolyte. Okay, conductance of all the ions produced by the ionization of 1 molar. Okay, 1 molar solution of an electrolyte. It's called as molar conductance, or lambda m is equal to specific conductance per volume of 1 molar electrolyte solution. So specific conductance into 1 molar solution of, or 1 molar or volume of 1 molar. Okay, volume of 1 molar solution of electrolyte. So volume will be in centimeter cube. Okay, so volume of 1 molar electrolytic solution. Okay, electrolytic solution. So what will be the unit? Lambda m is equal to 1000 into kappa by 1 molar. 1 molar or C. Okay, so this molar is mole liter inverse. Unit of mole. 1 mole is equal to mole liter inverse. Liter inverse is mole centimeter raised to -3. Okay. Kappa is yes centimeter raised to -1 by mole centimeter raised to -3. So unit will be yes mole inverse centimeter square. SI unit will be Cman mole inverse meter square. This will be the SI unit of molar conductance. Okay. Next, equivalent conductance. Equivalent conductance, lambda equivalent, denoted by lambda equivalent. So it is the conductance of all the ions produced by the ionization of 1 normal solution of electrolyte. Okay, it's the conductance of all ions produced by the ionization of 1 normal solution of electrolyte. Okay, 1 normal solution of electrolytes. 1 normality means ions in 1 gram equivalent of electrolyte. Okay. Ions in 1 gram equivalent of electrolyte is 1 normal. So how can we convert? That is lambda equivalence. How can we find the unit? Lambda equivalent equals specific resistance into, that is kappa. Specific resistance into volume containing 1 gram equivalent of electrolyte. Okay. Volume containing 1 gram equivalent of electrolyte. Okay. Now, this is equal to kappa into 1000 by normality. Instead of molarity, molar in molar conductance, here normality, normal in solution. Then what will be the SI unit? SI unit will be same, that is kappa m raised to minus 1 divided by meter cube. Okay, this is volume in meter cube. So by cancellation it will be meter square equivalent inverse. Okay, this will be the SI unit of lambda equivalent, and there is a relation between molar conductance and equivalent conductance. Okay, this is important. Lambda molar is equal to lambda equivalent into n factor. Okay, into n factor. Now, how can we convert this CGS unit into SI unit? Okay, the unit of lambda molarity is S centimeter square mole inverse. Okay, so 1 S meter square mole inverse, we can convert it as 1 Siemens. 1 will be converted to 10 raised to 4 into, because 1 meter 100 centimeter. So 1 meter square 10 raised to 4 S centimeter square mole inverse. Okay, so 1 S centimeter square mole inverse will be equal to 10 raised to minus 4 Siemens meter square mole inverse. So like this we can do the conversion while doing the problems. Okay, this much about equivalent conductance.